Good day, everyone. Today we are going to discuss about Chapter 9, which is the Database Management Systems. I am Alexandria Perez, together with Eloisa Reyubal, Cassandra Reyes, and Abigail Rodriguez. So first, we have the flat file versus database environment. So the best way to present the virtues of the database model is by contrast with the flat file model, because when we say flat file, it is a legacy system in which the user owns the data file. So this exclusive ownership of data is a natural consequence of two problems associated with the legacy system era. The first problem is a business culture that erects barriers between organizational units that inhibit entity-wide integration of data. The second problem stems from the limitations in flat file management technology. For us to better understand what flat file data management is, we have these illustrations. As we can see, we have three users, 1, 2, and 3, and they do have their corresponding programs and their own data. So data A, B, and C is exclusive for user 1, X, B, and Y is for user 2, and LBM is for user 3. So ganun nag-work yung flat file data. So, may kanya-kanyang data every user. Meaning, ang nakaka-access lang ng data A, B, and C is si user 1. And dito pumapasok yung data redundancy in where nagkakaroon tayo ng multiple files just for one data. For example, if we look at here, data B is repeated 3 times, not just to para lang ma-suffice natin yung needs ng every user. So, 3 beses nagkaroon tayo ng file just for one data. With that, dito pumapasok yung flat file problems. So first, we have data storage, in which it creates excessive storage costs of paper documents and or magnetic form. So since mas madami nga, or kumbaga, mas dami tayong file sa isang data, nagkakaroon or mas lumalaki pa yung data storage for just one data. Kumbaga, nagiging triple pa to, katulad nung sa data B. So next, we do have data updating. So any changes or additions must be performed multiple times. So imbes na isang beses lang tayo mag-update ng isang file, pero madami tayong file just for one data. So ganun kadami din natin ito i-update. Next, we do have the currency of information, and this happens on updating kasi since mas madami tayong files just for one data, may times na nagkakaroon ng failure to update all affected files. And lastly, we have task dependency, in where the user is unable to obtain additional information as his or her needs change. So, para mas maintindihan natin to, let's go back to the illustration. For example, data A, B, and C is only exclusive for user 1. However, data C, for example, kailangan ito ni user 1 or user 3. Pero since exclusive ito kay user 1, syempre kahit existing si data C, hindi ito ma-access ni user 2 or 3. Okay? Kaya dito pumapasok yung database management system, in where it is a special software system that is programmed to know which data element each user is authorized to access. And its purpose is to provide controlled access to the database. So, ayan. Ito yung database concept natin. Again, we do have 3 users. Then, the program to run the data. And then, we do have the database management system here, na kung saan ito yung nagiging or kumbaga yung medium na ginagamit para magkaroon tayo ng controlled access to the database. And what is unique here is that meron na lang isang database para sa lahat ng data or lahat ng information. So if ever user 1 wanted to access user C, then he can access that, and same as user 2 kasi meron na lamang tayong isang database para sa lahat. And this is beneficial, of course, since there would be no data redundancy since each element is stored only once. So, hindi na kailangan ng multiple data just for one file. And then, we have single update. So, it only requires only a single update procedure since isa nga lang yung file for every data. Next, we have current values, in where a change any users makes to the database yields current data values to all users. So for example, if data A or B is updated, then if users 1 or 2 access any of that data, then the information that they would get is up to date. Okay? And lastly, task data independence. So users have full access to the domain or the data available to the firm. So any data that they wanted to access or that they needed, then any user can access that. Hindi katulad sa flat file na may limitation kasi nga may exclusivity. What is unique in this database management system is, ang main concept niya is data sharing or absence of ownership. Okay? So if we remember, when we say flat file, it is exclusivity of data, so may exclusive ownership, while the database management system is absence of data of ownership or data sharing. So next, we have the three conceptual models, which are the hierarchical rather, network, and relational. Because of certain concept similarities, the hierarchical and the network bases are termed navigational or structured models. The way that data are organized in these early database systems forced users to navigate between data elements using predefined structured paths. The relational model is far more flexible by allowing users to create new and unique paths through the database to solve a wider range of business problems. So, even though maraming limitations, since una nga, one of the, parang unang models, yung hierarchical and network, this is still used to support mission-critical functions. However, of course, since sobrang flexible ng relational, most modern systems, ito na yung ginagamit. And this would be further discussed as we move on with our discussion. But for now, we would discuss the elements of the database environment, which would be discussed by Eloisa Riobal.
Good day everyone, I'm Eloisa Riobal and I'm going to discuss the elements of the database environment. So first, let's take a look at this illustration of the elements of database concept that can be found on page 402 of our book. This illustration summarizes the scope of my report, and here you can see different terms. So let us analyze this illustration and find out what are those terms and which of them are included in the elements of the database environment. In the presented illustration a while ago, the four primary elements are the users, the DBMS or Database Management System, the database administrator, and lastly is the physical database. I will discuss each of the elements and the other concepts or processes related to them. Our first element is the users. They are the one who access the database, and they can do that in two ways. First is via user application programs that the system's professional prepare, and second one is via direct query. Under the first method, using the application program, the programs send data access requests or calls to the DBMS, which validates the request and retrieves the data for processing. Under this mode of access, the presence of the DBMS is transparent to the users. While via direct query, as you can see in the illustration, it does not require a formal user program. Here, the DBMS has a built-in query facility that allows authorized users to process data independent of professional programmers. Now let's move on to our second element, which is the Database Management System or DBMS. The main goal of the Database Management System is to provide controlled access to the database by assisting or preventing the access of the users, and each DBMS model accomplishes this objective differently. But here we have the four common features of the Database Management System. The first is the program development. The DBMS contains application development software. Both programmers and end users may employ this feature to create applications to access the database. This program is the one to be used in the one method of accessing the data as discussed earlier. Second feature is the backup and recovery. During processing, the DBMS periodically makes backup copies of the physical database. It is a very important feature of the DBMS since in the event of disaster that renders the data unusable, the DBMS can recover an earlier version that is known to be correct. And the third one is the database usage reporting. This feature captures statistics on what data are being used, when they are used, and who uses them. Those information are used by the database administrator. Lastly, the database access. This is the most important feature of a DBMS to permit authorized user to access the database. Since the main goal of using a database management system is to provide controlled access. And from our illustration, we can see the three software modules facilitate this task. These are the data definition language, data manipulation language, and the query language. Let's define them one by one. The data definition language is a programming language used to define the physical database to the DBMS. The definition includes the names and the relationship of all data elements, records, and files that constitute the database. The DDL defines the database on three levels called views: the internal view, the conceptual view or schema, and the user view or subschema. So before going to the next software module, let's discuss first the three views of data definition language. The internal view. The internal view presents the physical arrangement of records in the database. This is the lowest level of representation. The internal view describes the structure of records, the linkages between them, and the physical arrangement and sequence of records in a file. There is only one internal view of the database. Next is the conceptual view or schema. This represents the database logically and abstractly. This view allows users programs to call for data without knowing or needing to specify how the data are arranged or where the data reside in the physical database. There is also one conceptual view for the database. User view or subschema. The user view defines how a particular user sees the portion of the database that he or she is authorized to access. To the user view is the database. Unlike the internal and conceptual views, many distinct user views exist. For example, a user in the personal department may view the database as a collection of employee records, without him knowing that in the inventory control department, the database is viewed as the supplier in inventory records. And to illustrate the roles of these three views, let's look at the typical sequence of events that occurs in accessing data through a DBMS, or what we call the DBMS operation. This illustration from the page 403 of the book shows an overview of a DBMS operation, but it can also be explained by the following steps or processes. So the first step in DBMS operation is when a user program sends a request or call for data to the DBMS. The call is written in a special data manipulation language that is embedded in the user program. Then the DBMS analyzes the request by matching the call data elements against the user view and the conceptual view. If the data request matches, it is authorized and processing proceeds to step 3. If it does not match the views, access is denied. Then the DBMS determines the data structure parameters from the internal view and passes them to the operating system, which performs the actual data retrieval. Data structure parameters describe the organization and access method for retrieving the requested data. Using the appropriate access method, the operating system interacts with the disk storage device to retrieve the data from the physical database. The operating system then stores the data in a main memory buffer area managed by the DBMS. Then the DBMS transfers the data to the user's work location in the main memory. At this point, the user's program is free to access and manipulate the data. And lastly, when processing is complete, Steps 4, 5, and 6 are reversed to restore the processed data to the database. Now that we fully discussed the first software module, the data definition language, and all its related concepts, we can finally move on to the second software modules for database access used in database management system, which is the data manipulation language. The data manipulation language is the proprietary programming language that a particular DBMS uses to retrieve, process, and store data. It is the one mentioned on the first step of our DBMS operation. Entire user programs may be written in the DML, or they can include selected DML commands to the programs that are written in universal languages. Examples of these are PL-1, COBOL, and Fortran. The advantages of using DML command is that it can be easily converted from flat file environment or earlier types of DBMS to work in the current database environment. Also, since it is easily convertible, it gives the organization a degree of independence from the DBMS vendor. The last software module is the query language. The query capability of the DBMS permits end users and professional programmers to access data in the database directly without the need for conventional programs. The standard query language for both mainframe and microcomputer DBMS is the IBM Structured Query Language, or SQL, but pronounced as SQL. By the way, the IBM is a global information technology company. So, SQL is a fourth generation non-procedural language with many commands that allow users to input, retrieve, and modify data easily. SQL is an efficient data processing tool, and it requires far less training in computer concepts and fewer programming skills than many languages. In using SQL, the user selects data visually by pointing and clicking at the desired attributes. The visual user interface then generates the necessary SQL commands automatically. This is an example that illustrates the use of the select command of SQL to produce a user report from a database called inventory. The select command is a powerful tool for retrieving data. For a clearer view, you can find it on page 405 of the book. On the bottom left, you can see the SQL command, which contains what to select, where will the data be gathered, and other condition that needs to be met. In our example, the SQL commands to select the item, description, on hand, warehouse location, and the VIN number from the inventory of the data which on hand value is greater than 300. On the bottom right is the report produced from the command, which came from the inventory records on the top table in our illustration. Now, after discussing the database management system and all related concepts to it, we can now move on to the third element of the database environment, which is the database administrator. The DBA is responsible for managing the database resource. And take note that this position does not exist in the flat file environment. The duties of the DBA fall into the following areas: database planning, database design, database implementation, database operation and maintenance, and database change and growth. Here is the illustration of the function of the database administrator under each of the areas. All of these are self-explanatory, so I will not explain it anymore, but for reference, you can find it on page 406 of our book. This illustration presents the organizational interactions of the database administrator. As the users send formal requests for computer applications to the system's professionals or programmers of the organization, the requests are handled through formal systems development procedures, which produce the program applications. But the user requests also go to the database administrator, who evaluates this to determine the user's database needs. Once this is established, the DBA grants the user access authority by programming the user's view or the subschema. By keeping access authority separate from systems development, the organization is better able to control and protect the database. Intentional and unintentional attempts at unauthorized access are more likely to be discovered when these two groups work independently. As the illustration shows, the database administrators do not only work with the end users but also to the management, operations, and the system professionals. In our illustration a while ago, included in the important function of the DBA is the creation of the maintenance of the data dictionary. So what is the data dictionary? The data dictionary describes every data element in the database. This enables all users and programmers to share a common view of the data resource and greatly facilitates the analysis of user needs. And now we're at the fourth major element of the database environment, which is the physical database. This is said to be the lowest level of the database. The physical database consists of magnetic spots on magnetic disk. The other levels of database are abstract representations of the physical level. At the physical level, the database is a collection of records and files. Relational databases are based on the index sequential file structure, which facilitates both direct access to individual records and batch processing of the entire file. Multiple indexes can be used to create a cross-reference called an inverted list, which allows even more flexible access to data. That is all for my report. We will understand more about the relational database model in the next topic, which will be reported by Abby.
So thank you. So now let's move to our next topic, which is the relational database model. The relational model portrays data in the form of two-dimensional tables, such as database table. Its strength is the ease with which tables may be linked to one another, while a major weakness are hierarchical and network databases. So, relational model supports the relational algebra functions of restrict, project, and join. So, here, restrict extracts specified rows from a specified table. So, in this operation, it creates a virtual table na hindi nag-exist physically that is just subset of the original table. So, next is project. So, unlike restrict, it extracts specified attributes or columns from a table to create a virtual table. So, join, it builds a new physical table galing sa dalawang table that consists all concatenated pairs of rows from each table. So, dito sa join, as you can see, there is a relationship between them. So these building blocks are then used later in the chapter to design a small database from scratch. So next is, let's discuss some relational database concepts. So first is entity. So this is anything about which organization wishes to capture data. Pwede maging physical tulad ng inventories, customers, or employees. Pwede rin maging conceptual such as sales, accounts receivable, or accounts payable. So, kailangan ma-identify ng system designers first ang entity to prepare a model of them na kagaya nito. Ayan. So, the blueprint for creating the physical database is called the data model. So, the entity relationship diagram or ER na pinakita ko kanina is the graphical representation used to depict the model. So next is occurrence, that is used to describe the number of instances or records that pertain to a specific entity. Halimbawa nito, kapag ang isang organization ay may 100 employees, therefore, the employee entity ay masasabing mayroong 100 occurrences. On the other hand, attributes. So these are the data elements that define an entity. For example, an employee entity may be defined by the partial set of attributes such as name, address, job skill, years of service, and hourly rate of pay. So let's proceed to association and cardinality. Association represented by a line connecting two entries. So it describes by a verb such as ships, requests, or receives, while cardinality is the degree of association between two entities. So this is the number of possible occurrences in one table that are associated with single occurrence in a related table. So this is used to determine primary keys and foreign keys. So to elaborate this more, this is an example of an entity association. Again, ang kaninang definition natin ng association is a line connecting two entities in a data model. So dito sa figure, ang entity associations ay yung line sa gitna. Yung mga is assigned, is provided, places, and supplies. Dahil yun ang mga linya na nagkokonekta sa dalawang entities. So the employee is assigned a company car, as stated in example 1, and manager is provided a laptop, and so on. So how about cardinality? As of our definition a while ago, cardinality is a degree of association between two entities. So it can be 0 or 1, 1 and only 1, 0 or many, and 1 or many. So these are combined to represent logical association. Sa example 1, mayroong 1 or 1 cardinality sa dulo ng employee at 0 or 1 cardinality naman sa kabila. Therefore, results to 1:1 association. Same as example 2. Ito ay 1:1. Ang example 3 and 4 naman ay 1:many dahil sa sign na parang greater than na nakikita nyo sa screen. Sa sales order and inventory. So lastly, sa example 5 ay many-many association. Bakit? Kasi may one or many cardinality ang both sides. So, how to properly design relational tables? So, dapat ang properly designed relational tables should contain 4 characteristics. So, ano nga ba yun? So, each row in the table must be unique in at least one attribute, which is the primary key. So, tables are linked by embedding the primary key into the related table as foreign key. So, next is all attribute values in any column must be of the same class of data or type. Next is each column in a given table must be uniquely named. However, different tables may contain columns with the same name. So, next is tables must conform to the rules of normalization. Ibig sabihin, they must be free from structural dependencies or anomalies. So, ano nga ba itong mga anomalies? So, we have 3 types of anomalies. So, ano nga ba uli ang mga ang anomalies? So, it is the negative operational symptoms of our database. So, usually, it is caused by improperly normalized tables in a database management system. So, first type of anomalies is update anomaly. It is a modification on an attribute must be made in each of the rows in which the attribute appears. Next is insertion anomaly. A new item cannot be added to the table until at least one entity uses a particular attribute item. Next is deletion. If an attribute item used by only one entity is deleted, all information about that attribute is lost. So kapag nagkaroon ng negative operational deletion, then madidelete yung ibang attributes at madidelete din yung lahat ng information about it. So to address these problems or the negative operational symptoms of the database, we have normalization process. So in the previous slide, we had discussed some database anomalies. So these anomalies can be corrected by creating additional relational tables. So to address these problems, we have the so-called normalization process, wherein it involves identifying and removing some structural dependencies from the table under review. So the normalization process is a process which systematically splits a normalized complex tables into smaller tables that meet two conditions. One is lahat ng non-key or secondary attributes in the table are dependent on the primary key and are independent of the other non-key attributes. So kasi ang problema natin kanina is sa insert, delete and update anomalies, dahil related ang mga yon, most likely we have a problem on inserting, updating, deleting. So sineseparate or ini-split through normalization process yung mga table into smaller so that it could avoid some anomalies. So when a normalized tables are split and reduced to third normal form, they must then be linked together by foreign keys. So even though they are broken down into smaller tables, still they are being linked to each other. Kasi yun naman ang purpose ng relational database, to link various tables on a particular step. So here are the steps in the normalization process. So sa user view, you will have a normalized table. So ang gagawin doon sa table in first normal form ay i-remove ang partial dependencies, then magkakaroon ng second normal form. Then remove transitive dependencies and you will have the table in third normal form. So dito, na-normalize yung mga tables natin. So since we have a problem on updating, so same as insertion anomalies, which can result in unrecorded transactions and incomplete audit trails. And for deletion anomalies, wherein kapag ang isang attribute ng isang entity ay na-delete, ay madidelete din ang lahat ng mga information, which can cause the loss of accounting records and destruction of audit trails. So, kailangan maintindihan ng mga accountants ang data normalization process at dapat kayang ma-determine kung ang database ay talagang properly normalized. So, for the next topic, designing relational databases, here is Cassandra Reyes.
Thank you, Abigail. So, after learning about relational database models, we are now diving into the process of database design. In this discussion, we will be able to examine the steps involved in creating a relational database. Before we get into the 6 phases, we must keep in mind that database design is a portion of a much larger system development process that involves extensive analysis of user needs, which will be discussed in the following chapters. But here, we will be only focusing on the 6 phases of database design, which are collectively known as view modeling. So first is to identify entities. Second, construct a data model showing entity associations. Third, add primary keys and attributes to the model. Fourth, normalize the data model and add foreign keys. Fifth, construct the physical database. And lastly, prepare the user views. So let us first discuss the first phase, which is to identify entities. Take note that for the entirety of our discussion in this particular topic, we will be demonstrating the 6 phases in a simplified purchasing system. So going back, to identify entities, we must first analyze these key features. Number 1, the purchasing agent reviews the inventory status report for items that need to be reordered. Number 2, the agent selects a supplier and prepares an online purchase order. Number 3, the agent prints a copy of the purchase order and sends it to the supplier. And number 4, the supplier ships inventory to the company. Upon its arrival, the receiving clerk inspects the inventory and prepares an online receiving report. The computer system automatically updates the inventory records. So while analyzing, mayroong mga nabanggit na documents. And here are the examples of a user view of each document. We have here an inventory status report, which is already discussed in the previous topic. We also have here the user views of a purchase order and receiving report. Before we move on, please take note of the details included in each document as these are vital for the next phases. Usually, entities are represented as nouns in a system description. And in our sample situation, we have multiple candidates that can be identified as entities. These are the purchasing agent, receiving clerk, inventory, supplier, inventory status report, purchase order, and receiving report. At first glance, we might think that all of these candidates were important and to be included into the database. But not all of these candidates are true entities. So to pass as valid entities, these two conditions must be met. First is an entity must consist of two or more occurrences. So if, for example, we only have one supplier, then the supplier entity fails to this condition and will not be regarded as a true entity. And for the second condition, an entity must contribute at least one attribute that is not provided through other entities. So basically, that entity must have a unique attribute. So for discussion purposes, we assume that after examining the candidates, the inventory, suppliers, purchase order, and receiving report pass the two conditions. After identifying the entities, let's now move on to the second phase, which is to construct a data model showing entity associations. You can see in this figure the data model for our sample problem. To discuss each associations, let's proceed to the next slides. We can see here the cardinality symbol, which represents the zero or many-to-many association between the purchase order and inventory entities. This means that each inventory item may have been ordered many times or never ordered in the current business period. For the inventories and supplier entities naman, there is a many-to-many association between them, which means that one or more vendors supply each inventory item and each of them supplies one or more items of inventory. Next, we can see here that there is a 1 to 0 or many association between the supplier and the purchase order entities. This means that in the current period, each supplier may have received 0 or many purchase orders, but each order goes to only one supplier. There is a 1-to-1 association naman between the purchase order and receiving report entities. This means that in every single purchase order, there is a corresponding single receiving report. Likewise, in every receiving report, there is only one purchase order on it. Lastly, the association between the receiving report and inventory entities is 0 or many-to-many. This signifies that within the period, each item of inventory may have been received many times or never. Also, each receiving report is associated with at least one and possibly many inventory items. So before we move on to the next phase, we must take note that the many-to-many associations need to be resolved by finding the entity that will link them. So for the third phase in database design, we need to add primary keys and attributes to the model. We know that primary keys logically defines the non-key attributes and uniquely identifies each occurrence in the entity. So in our identified entity, here are their primary keys. We assign part number as the primary key for inventory entity, supplier number for supplier entity, purchase order number for the purchase order entity, and receiving report number for the receiving report entity. After assigning the primary keys, our next step is to identify the attributes of each entity. I mentioned a while ago to take note of the details in the user view documents, and this is because those details are from the data model. So as you can see here, these attributes will be soon reflected to the user views. Let's now proceed to the fourth phase, which is to normalize data model and add foreign keys. In the process of normalization, there are some issues that may arise. And in our problem, these are the issues. First is the repeating group data in the purchase order. The attributes part number, description, order quantity, and unit cost are repeating group data in the purchase order entity. To resolve this issue, we created another entity, which is the purchase order item detail, and transferred the repeating group here. This will also resolve the many-to-many association and serve as the link between the inventory and purchase order entity. The second issue is to resolve the repeating group data in receiving report. The repeating group in the receiving report entity is the part number, quantity received, and condition code. Just like what we did earlier, we transferred the repeating group in the new entity, which is the receiving report item detail. And we assigned the attributes receiving report number and part number as the composite primary key. This will resolve the many-to-many association and serve as the link between the receiving report and inventory entities. For the last issue, we must resolve the transitive dependencies. We can see here that the purchase order and receiving report have attributes which are redundant with the data in the inventory and supplier entities, and this occur because of transitive dependencies. The transitive dependencies simply means that the primary key does not define these non-key attributes. So to resolve this issue, we need to drop these attributes from the purchase order and receiving report entities. Before we move on to the next phase, notice that aside from the previously discussed new entities, we also added here a new entity to link the inventory and supplier entities. Furthermore, we also embedded foreign keys to physically show the association between entities. So for the fifth phase, we will now construct the physical database. In this figure, it illustrates the 3NF table structures for the database. The primary and foreign keys linking the tables are represented by dotted lines. Using this, we can create the physical tables and populate them with data. This is an involved step that must be carefully planned and executed and may take many months in a large installation. So basically, it is a tedious process. Once this is done, we can now proceed to our last step. Our last phase is to prepare the user views. As I've mentioned earlier, the user views are constructed from the attributes located in several tables. Let's take for an example this purchase order. The encircled numbers are for cross-referencing. As you can see here, the number 2 and number 3, supplier name and address, can be found here in the supplier entity. And it is also the same for other details. It is also important to note that this table can produce several user views such as receiving report and inventory status report. So that is all for this topic. Let's now move on to the last topic on this chapter, which will be discussed by Alexandria.
Thank you, Cassandra. Now we have database in a distributed environment. Distributed data processing, or DDP, is alternative to a centralized approach. It is organized around several information processing units distributed throughout the organization. Each information processing unit is placed under the control of the end user. And distributed data processing does not always mean total decentralization. Kasi kahit na it was distributed, the information processing units are still connected to one another and coordinated. So typically, DDP uses a centralized base. The database can be distributed similar to the distribution of the data processing capability. So centralized databases. This is centralized databases in the distributed database processing. So remote users send requests via terminals for data to the central site, which processes the request and transmits the data back to the user. The central site performs the functions of a file manager that services the data needs of the remote users. So here in this illustration, we can see that we have the central site that contains the central database. So what is unique about this is we have the central location which has the information or the database. So kung kailangan man ng information na ito or ng kahit na anong data from different sites, then they can only have that access or that information through this database. Okay? So DDP is an important consideration in planning, to which it addresses the issue about the database, which can be centralized or distributed, and if distributed, it can be partitioned or replicated. Okay? So now we have database currency. So this occurs in distributed database processing with centralized database. During transaction processing, data will be temporarily inconsistent as records are read and updated. So this happened because the DDP uses a centralized database. Kasi nga 'di ba kapag centralized yung database, dun lang tayo kumukuha ng information, and may mga pagkakataon that users wanted to access the same data, the same information simultaneously. For example, site A and site B wanted to look at the information about a certain transaction, specifically accounts receivable, then they could access it simultaneously. However, due to that simultaneous access, dahil sabay sila, may mga pagkakataon na nagiging inconsistent yung records kasi baka mamaya sabay nilang ginagalaw or sabay nilang ina-update yung that same file. That is why the solution that we have is the database lockout. It is a software control in which it prevents multiple access to data. So kapag sinabi naman nating database lockout, di ba? For example, again, site A wanted to look and also site B wanted to look at that specific transaction. Ang gagawin nitong database lockout is that habang ginagamit ni site A yung transaction about accounts receivable, ilalock niya ito para hindi magkaroon ng access yung iba pang sites hanggang sa matapos si site A. So pag natapos na si site A, saka lang niya bibigyan ng access si site B, and ganun din yung gagawin niya para hindi magkaroon ng access yung ibang site, and of course, para ma-ensure na yung updating is always accurate. So procedures are necessary to keep information processing units from reading inconsistent data and from writing over a transaction being written by another information processing units. So now we have partition databases. So it splits the central database into segments or partitions that are distributed to their primary users. Kapag partition database from a central database, then nagkakaroon ng partitions or hinahati into segments or partitions. So the advantages of this is storing data at local sites increases users' control, permitting local access to data and reducing the volume of data that must be transmitted between sites, and reduces the potential data loss from disaster. So now we have the deadlock phenomenon. So this is a problem with partition database. where it occurs when multiple sites lock each other out of data that they are currently using, and special software is needed to analyze and resolve conflicts. So here in this illustration, makikita natin, we have three sites, no? Since kapag nga partition, no, nagkakaroon tayo ng mga segments or partitions. So for site 1, it has data A and B, site 2 has C and D, site 3 has E and F. Ang nangyayari kasi dito sa deadlock is that, for example, site 1, it locks data A, but is waiting for data C. And data C, makikita natin ito sa site 2. Kaso nga lang, site 2 lock the information in data C. Pero it is waiting for the information for data E. And data E, makikita natin ito sa site 3. Okay? Ang kaso nga lang, site 3 lock data E. No? And it is waiting for information in data A. Pero if we look at site 1, nakalock ito doon. No? So, ganito yung nangyayari kapag deadlock. Kumbaga, nagkakaroon tayo or pina-prevent nila na mag-move yung transactions kasi nga they lock each other, okay? In a distributed environment, multiple sites will lock out each other, thus preventing each from processing the transaction. Resolving a deadlock usually involves sacrificing one or more transactions. This must be terminated to complete the processing of the other transactions in the deadlock. And as mentioned, special software is needed for it to be resolved. Now we have replication databases. So, duplication of the entire database for multiple information processing units. Kung sa partition, from a central database, nagkakaroon tayo ng segments or partitions. Dito naman sa replication, duplication siya ng entire database. Okay? So, effective for situations with a high degree of data sharing but no primary user. It also supports read-only queries. So, kapag read-only, di ba, pag meron tayong mga data or information, mga files na nakikita na kung saan hindi natin ito pwedeng i-edit. Pwede lang natin silang mabasa, pwede lang natin makita yung information, but we couldn't edit that information, no? Data traffic between sites is reduced considerably kasi hindi tayo nagkakaroon ng deadlock, no, na kung saan nilalock nung sites yung information. Dito sa replication, walang ganun. Now we have concurrency control. So database concurrency is the presence of complete and accurate data at all information processing unit sites. With replicated databases, maintaining current data at all locations is difficult, no? Kasi nga, since magkakaroon tayo, or may duplication tayo ng databases, nagkakaroon tayo ng multiple databases. So, kapag nag-update tayo, okay, dapat we need to also maintain the other databases. And first, the solution for that is timestamping, in which it used to serialize transactions and prevent and resolve conflicts created by updating data at various information processing units. Ang ginagawa nitong timestamping is that kapag ginalaw or na-update ang isang file or data, nagkakaroon ito ng information katulad ng kailan na-update, saang site, ano yung mga ginalaw, and ganon, para madaling matrace kung alin ba yung mga information na nabago, kung alin ba yung mga dapat nating baguhin, kapag, lalo na at para maiwasan natin yung mga conflicts, okay? So lastly, we have distributed databases and the accountant. So the following database options impact the organization's ability to maintain database integrity, to prevent audit trails, and have accurate accounting records. So, syempre, with that options, kung paano natin i-store or mamimili kung paano natin anong gagawin natin sa ating database, and it is dependent din syempre sa ating mga needs. No, it could be centralized or distributed. If distributed, replicated ba ito or partitioned, okay? If replicated, total ba or partial replication lamang? If partitioned, what is the allocation of data segments among sites? So, syempre, for us that we are knowledgeable about this, pwede kumbaga malalaman natin or we can choose which database is applicable sa ating mga pangangailangan. For example, we only want read-only. So gusto lang natin na yung mga users mabibasa lang nila yung information pero ayaw natin ginagalaw ito. So we could choose that. Okay? So it is under the replication. Kung gusto mo naman segments or partition, then you also have that option, no? So that's all for chapter 9, which is the database management systems. Thank you. Now we are ready for your questions.